students. So we'll be solving exercise 1.1 continuation of recap session. So exercise 1.1 not 1.1 8.1 question number 9. In triangle ABC right angle at B, if tan A is 1 upon root 3, find the value of sin A cos C plus cos A sin C. Cos A cos C is minus sin A sin C. So first in this case, first you make a right angle triangle. Make a right angle triangle. So we are drawing a right angle triangle. Okay. It is given that it is a right angle triangle ABC which is right angled at B. So this is A and C. As we know that trigonometry we study with respect to the ratio of sides with respect to acute angles. So these are our acute angles A and C. What is tan A value is given? So with respect to tan A it is given that. So the solution tan A is given as 1 upon root 3. Tan A value is 1 upon root 3. Ratio is given as 1 upon root 3. But what does the trigonometric ratio say? Tan A formula is opposite side upon adjacent side. So which is the opposite side of angle A? That is the side is BC, and which is the adjacent side, that is AB. BC upon AB. I hope this is clear. So opposite is the one which is here. See, for angle A, BC is the opposite side. For angle A, which is adjacent side is, and the fixed side is hypotenuse. Correct? Once you label it, you will understand. This is with respect to angle A. With respect to angle C, opposite and adjacent side will change. Now here I have BC upon AB. Therefore, I can say BC upon AB is nothing but 1 upon root 3. I hope. Right? So 1 upon root 3 you get. It again I am telling you, it is in the form of ratio. So here you have to take a common multiple. You should say this implies I will take therefore BC equals to 1k and AB equal to root 3k, where k is some positive integer, where here k is a common multiple which is a positive integer. Okay, so I am assuming k, which is given in NCERT. You can take any this, you can take x also, but you write there that x is a common multiple we are taking. So BC is 1k, that is nothing but k, and AB equal to root 3k. As I said, first in a triangle, if two sides you come to know, find the third side by using Pythagoras theorem. So I know what is BC, I know what is AB, so you can find by Pythagoras theorem AC. So by Pythagoras theorem when you apply, we find hypotenuse square. So AC square equals to students AB square plus BC square. Okay, so AC square equal to AB square plus BC square. So here we get AC square equals to, what is AB square? AB square is root 3k the whole square. What is BC square? BC square is nothing but k square. So here we get 3 square is 3k square plus k square, that is 4k square, right? So AC square we get 4k square. We are interested in AC. So we take square root on both the sides, taking square root on both the sides. So what we get? We get AC equals to, actually we get plus or minus 2k, but we consider only the positive value. So I will take here in this case AC equal to 2k. Correct? So we know all the three sides now it is known. We know AC as 2k. So we know AC, let's try this. So AC is nothing but 2k. We got BC as k and AB is nothing but root 3k. Once we know all the three sides, we can find any trigonometric ratio of the sides with respect to angle A and C. Let's see the first one. So we require, what they have asked, sin A into cos C plus cos A into sin C. Correct? So what is sin A? Sin A is nothing but opposite upon hypotenuse. Let's see here, which is the opposite side here, BC. So k upon hypotenuse, that is 2k. I am not writing the formula, you can write directly. Okay, cos C. So cos C means from C we have to view. Cos is nothing but adjacent upon hypotenuse. So k upon 2k. I hope this is clear. Sin is nothing but opposite upon hypotenuse. So from A I viewed cos C. So from C you have to see cos formula is adjacent upon hypotenuse. So k upon 2k. Plus again cos A. So cos A is from A we have to view adjacent upon hypotenuse. So adjacent here is root 3k upon 2k. Similarly sin C. Sin C is from here. What is the formula for sin? Opposite upon hypotenuse. So again we get root 3k upon 2k. Correct? So this k will get cancelled, as you can see. Okay, so we are left with 1 and here 2 is 4 plus root 3 to root 3 will give you 3 and 2 is 4. So here we have the LCM is 4. So we have 1 plus 3. So we get 4 upon 4, that is nothing but 1. So we got the value of the first term equal to 1. The only thing you have to be very careful, that is whether it is A or C. Any angle is there, first you see and then you apply. The second sub question, let's solve that also. Second sub question, we have cos A into cos C, students, minus sin A cos C. Okay, so we have cos A again. Cos A from here will do adjacent upon hypotenuse. So we have root 3k upon 2k. Cos C, so cos C from here I view adjacent upon hypotenuse, that is k upon 2k, minus I have here sin A. What is sin A? Opposite upon hypotenuse. So here k upon 2k, and here sin C is nothing but opposite upon hypotenuse. So we have root 3k upon 2k. So as you see here, k, we are cancelling k, actually they are same terms if you observe carefully. So we have root 3 and 2 is 4, correct? And here we have minus root 3 and k gets cancelled, so 4. So they are one and the term, same term. So we give the answer as 0. So as you understood that in this sum, here, in this sum what we have done, in the triangle we found the third value. Once we find the third value, third side we have found out, then we have just applied the trigonometric ratio and found the value. Is it understood? Now we do the next sum, that is question number 10th. In triangle PQ are right angled at Q, PR plus QR equal to 25 cm, PQ equal to 5 cm, determine the value of sin P, cos P and tan P. So as I said, we will draw a triangle, find the three sides answers, the length of the three sides. Once the three sides are known, then we can find very easily. Now here, just see, some condition is different, that is what is different. So let's first make a right angle triangle. So I have drawn a right angle triangle. It is right angled at Q. So please be very careful. It is right angle at Q. So obviously the acute angles are P and R. Here it is given PQ is 5 cm. So this is fixed. Can you see? PQ is 5 cm. They have given PR plus QR equal to 25 cm. It is just like framing the equation that if sum of two number is 10, what are the two numbers? Like if one number, if sum of two number is suppose 10, if they are asked to form a linear equation, we'll assume let one number be x, another number be y. So x plus y equal to 10 we will write. Suppose if it is given in only one variable. So if one variable is x, suppose sum of two number, if I say sum of two number is 10, for example I gave you 10. So here I say if one number plus the other number will give you 10. We don't know the number. Suppose if I am asking you in one variable, if one number is x, what will be the other number? You will take that x, you will say if one number is x, the other number will be 10 minus x. Other number will be 10 minus x. The similar lines, if the sum of these two sides is 25 cm, I'll assume one as x centimeter. Suppose let QR be x centimeter. So what will be PR 25 minus x? I hope this concept is clear. So here the challenge is only in this sum is to find all the three sides. They have given the relation. From this we have to find the sides. So as we all know, we'll be using the Pythagoras theorem. Okay. So let's assume. So here we'll start with solution. Here it is given that PQ in right triangle. So I can use the word RT in right triangle PQR. We know that, students, PQ equals to 5 cm and it is given that QR is x. QR is x centimeter. QR is x centimeter. Can we find what is PR? Okay. So, sorry. We have assumed let QR equal to x centimeter. Therefore, PR will be equal to 25 minus x. As it is given that PQ plus PR plus QR equal to 25. So, this is 25 minus x. PR is 25 minus x. We will apply Pythagoras theorem. So, by Pythagoras theorem, we know hypotenuse square equal to one side square plus other side square. So here we will take PR square equals to PQ square plus QR square, students. So what is PR square? 25 minus x the whole square equals to what is PQ square? That will give you 5 square. What is QR square? X square. Correct? Now this is in the form of A minus B the whole square identity. A minus B the whole square identity is A square minus 2ab plus b square. So let's apply 25 square is 625. is a square 2ab. So 25 2s are 50x plus x square, that is 3 square, equals to 25 plus x square. I hope this is clear. Whenever there is an identity, either of a minus b the whole square, a plus b the whole square, please apply the identity. So here we will get here x square get cancelled. So we are getting here 625 minus 50x equals to 25. So I'll take this 50x this side, bring the 25 this side. So I get 625 minus 25 equal to 50x. This will become positive. So 600 equals to 50x. Therefore, what is the value of x? X equal to 600 divided by 50. Correct? So the 0, 0 cancel. 5 12s are 60. So we got the value of x as 12 centimeter. So what we have assumed x? X is nothing but QR. Therefore, I can say QR equals to 12 centimeter. Can I find what is PR? Therefore, PR will be equal to, students, 25 minus x. 25 minus x, that is nothing but 25 minus 12. We all know 25 minus 12 is 13 centimeter. It forms a Pythagorean triplet 5, 12, 13. Once we got all the three sides, then there is no challenge left. Just we have to find the value. Right? So here we got sine p, we are asking. Sine p is nothing but again opposite upon hypotenuse. My opposite side with respect to p, which is the opposite side, QR. That is QR upon PR. Just now we found what is QR, that is 12 upon 13. Next they are asking cos p. So cos p is nothing but again from p. Cos formula is adjacent upon hypotenuse. So we have PQ, adjacent upon hypotenuse PR. So we have 5 upon 13. Next they have asked what is the value of tan p. Tan p is nothing but, what is the value of tan p? Opposite upon adjacent. Opposite upon adjacent. So what is opposite here? QR. QR is given us. We found that to be 12. So 12 and adjacent is nothing but 5. I hope this is understood how to find the value. So tan P is, I hope, okay, 12 upon 5. So we found out the value of each. So what was the challenge in the triangle? We just have to find out all the three sides. So here only this part was difficult. Rest exercise 8.1 is based on the same. You find all the three sides, apply the trigonometric ratio, you get very easily and you can solve. Okay, understood? Let's meet in next exercise.